Okay. Now in the ordinal logistic regression, okay, it's very close to what we did the other time. We have more than 2 categories, but you know what? They are ordered. The one we just did, they are not ordered. The levels of response variable, not ordered, but here they are ordered. Okay, now I'm going to give you an example. A researcher is interested in what factor influence medaling in Olympic swimming. Oh my God. Olympic is coming, I think in France, right? That's Paris this year, right? Okay. Now, relevant predictors include training hours, diet, age, and popularity of swimming in the athlete home country. The researcher believed that the distance between gold and silver. Now, take a look at it. The reward here are ordered. Gold, silver, bronze. They are ordered. And the distance between gold and silver is larger than the distance between silver and bronze. Okay? Now, another example. A study looked at the factor that influence the decision of whether to apply to graduate school. You know, when somebody finish your undergrad, they go, okay, do I need to apply to do? Is the graduate school worth it at all? Okay, college juniors are asked if they are unlikely, somewhat likely, or very likely. Those are ordered. Does that make sense? Those are ordered. Unlikely, okay, to somewhat likely, to very likely. Those levels are ordered. Does that make sense? You know, to apply to graduate school. Now, hence, our outcome variable has 3 categories, of course, as you can see. So data on the parental education status. That's one of the key explanatory variable to consider. Okay? Whether the undergraduate institution is public or private, where you currently are, is it public or private, and your current GPA is, is also collected. Now, the researchers have reason to believe that distances between these 3 points are not equal. You know, it is not only that they have to be ordered, but when the distances between them are not equal. Okay? Now, for example, the distance between unlikely and somewhat likely, you know, when I say unlikely, somewhat likely, the distance between them may be very short. You know, shorter than the distance between somewhat likely and very likely. Very likely. Does that make sense? Now, you know what I'm going to do now? The example that I have a data set that I pulled from University of California, once again, at Los Angeles. This is the data set. If you copy all of that into R, you're actually going to see this. Okay? Now you can see the parent education. You know, 1 and 0 here indicates maybe 1, the parent actually maybe go to school, 0 not. Then under the public is the where you are having your undergrad right now, whether it's a public or private university. Then your GPA. Okay. Now I need you to pay attention right now. I of us want to do let me have some understanding about your GPA. In the data, I want to know the minimum GPA here. I want to know the maximum. I want to know the median. I want to know the first quartile, and so on like that. Okay, this is just understanding, having some kind of understanding on the GPA. But how do we fit ordinal logistic in R? Take a look at this. Oh my God. Look at that. That's super cool, right? You're actually gonna write POLR. That is for ordinal. Look at that. POLR. My response variable here is apply. And apply has 3 levels. Unlikely, somewhat likely, very likely, right? What are my independent variable? The parent education that I call PARED, whether you attend public or private, then your GPA. Okay, now let's see how the result is going to be displayed. Oh my God. Do you know that polynomial regression would display results this way? Take a look at what you see now. We are back at T. Do you see T value? Okay, take a look at that. Why, if you take a look at what I have here, these are the, look at that, you can see the coefficient. But let me tell you this. We have additional stuff here that you need to put into consideration. That is for the intercept. The way ordinal logistic regression output is being displayed. Okay. The intercept, this is for the intercept. Why this one is the one for the slopes. Okay. And in the intercept is going to compare unlikely against somewhat likely, somewhat like, you can see unlikely against that. Where I stop here is where I'm going to start here, to very likely. Okay, you can see the ordering. How do we automatically generate that for you? Okay, now if I have this now, okay, now do you know that this estimate values, they are also log odd estimates, log odd estimates. Okay, now I need to pay attention to this now. Let's say, for instance, I actually want to get, here is a point estimate for each of them. Point estimate, a single value for the coefficient. And if I'm interested in the confidence interval, okay, I'm just going to do confit in R. Do you see? Confit of M. What is your M? Okay, what is your M? You can see M is what when you feed a model. Let me tell you this. When you fit a model in R and you write confit M, you know what you want to get? You want to get a confidence interval for the regression coefficient. Now, what I'm trying to tell you now, the confidence interval here is this. Okay, it's trying to give you for each of the explanatory variable. Now, let me now do this. How do we interpret? For instance, we want to interpret the effects of parents going to school on whether you how that will affect your choice of applying to graduate school. Okay, that is 1.0477, right? Let's approximate that. That would be 1.05 to 2 decimal, right? Do you see that? And it's positive. Look at what I'm going to say. For PAROD, for parent education, we will say that for 1 unit increase in parent education, you know the meaning of 1 unit increase in parent, that is going from 0 to 1. What is the meaning? It's going from 0 to 1 for parent. It said going from 0 to 1 means a parent moving from no education to education, like to having maybe education. You understand what I mean? Okay, because the parent education here is categorical. You remember the way we interpreted socioeconomic status the other time. We go from the low to what we're talking about. Okay, so here we expect a 1.05 increase in the expected value of apply on the log odd scale. Don't forget, on the log odd scales, because those estimates are log odd estimates. Okay, now, but that doesn't stop there, because it is not only parent education that we have. I have to tell the world, I have to adjust for other variables too. And that was why I said, given all of the other variables in the model are held constants. Now I'm going to do the same thing to the GPA. If I want to know the role, if I want to interpret the GPA now, okay, the GPA, take a look at that guy, 0.6159. I actually use 0.62, right? To 2 decimal. I said for a GPA, we will say that for a unit increase in GPA, if for GPA, you don't move from a class to class, so because GPA is continuous, random variable, because we're just going to say a unit increase in that. Okay, a unit increase in GPA will expect 0.62 increase in the expected value of apply in the log or scale, given that all other variables in the model are held constant. Do you see that interpretation now? That's super cool, right? Now, I told you something the other time. You know, if you come back here, we talk about the confidence interval. This is just the confidence interval on the log odd estimate for 95%. But if I want to drop log, can somebody remind me what to do? We did that in Poisson regression. If I don't want to mention log, what am I going to do? Exponentiate. Send me a message for extra credit. Please make sure you're keeping track of the number of extra credits you have. Imagine somebody having 20 and maybe you score 80 in the final. Sorry, not you, because you guys are brilliant. Maybe this guy scored 80 in the final and you're going to say, okay, you know what? Can you add my 20 to the 80 that I got? What is that going to amount to? That will be 100. I don't joke with my extra credit. Okay, now, if you take a look at this guy now, okay, if I want to remove the log, and instead of me to say log hard, I just want to say hard. Look at what I'm going to do. I want to find the odd ratio. This is the code of the exponentiation. Do you see that? ESP. Now that's exponentiation of what? Of your OR. Okay, OR equal to coefficient in CI. Okay, don't forget the CI. You've gotten the CI before here. Do you see? Your CI equal to confint into M. So this is now going to give you what you have right now. You know what that guy is going to give you? It's going to give you three things. The first three values, this guy, they are the point estimate of the odd ratio. Why the other ones are the confidence interval for the odd ratio. Does that make sense? Now, well, you know what I want to walk you through right now? I said, take a look at this. Take a look at this guy. Point estimate of odd ratio. Why this guy? Confidence interval for each odd ratio. Like for instance, for parent education, the odd ratio is 2.8511. Okay, and the confidence interval is from 1.6958. Now the question now, how do we interpret odd ratio? I want to show you how we interpret odd ratio now. For instance, I want to interpret this guy. How do I interpret that 2.85, which is the odd ratio? Now, this is the way I'm going to interpret that. Okay, I needed to take a look. I said, for student whose parent did attend college, the odds of being more likely, or be more likely mean very or somewhat likely versus unlikely. Unlikely, you know, you want to compare that with unlikely, is to apply is 2.8 times. Okay, that of student whose parent did not go to college, holding other variable at constant. When I say when the odd, you know, let's say the odd ratio is 1, what happens when the odd ratio is 1? It's 50-50. Whether the parent go to college or not. But when the odd ratio is greater than 1, then it's actually saying when the parent go to college, that may likely affect the decision of the children to also go to college. That's what it means. And if I want to do it in the other way around, depending on what I put, I can also say for student whose parent did not, if I want to start with student whose parent did not attend college, the odds of being less likely to apply is also going to be that. Is still the same. Does that make sense now? Now, you know what I want to do now? Take a look at this. I want to look at the effect of school type. You know, this guy, whether you attend public, you know why arrow is showing public? Because arrow coded private as 0. That's why it's showing public. Does that make sense? Now, let's look at the effects. Now, how do I interpret that odd ratio? And that is what I said here. For student in public school, okay, the odds of being more likely, okay, to apply is 5.71%. How do I get 5.71%? What you're going to do, if you come back here, you know, that guy to 2 decimal is going to be 0.9943, right? To 3 decimal. Now you're going to do 1 minus, I think I'm showing that here. Do you see this guy? 1 minus that multiplied by 100. That will give you 5.71%. So now to apply is 5.71% lower than private school students. Lower than private school student. And you're going to see why lower than private school student. If you go back to the estimate, the re-estimate, negative. This is negative. Negative is 0.6522. If you go back to original, the log or the log or the let me see. Let me go back. Yeah. If you come back to the original log or the estimate here, what do you see? You know, it's negative, right? Okay, so that was why you saw the lower. Now, what about GPA? Okay, you know the GPA here, the GPA, we are still talking about hard. Okay, how do we interpret that hard? Okay, take a look at here. For every 1 unit increase in the student GPA, the odds of being more likely to apply, okay, versus you not applying is multiplied by 1.85 times. That is more because it's greater than 1. Okay, and that is going to increases 85%. Why? Why do you say that? Take a look at this. 1.85 is an increase. If you want to look at it by multiplying by 100, why it's 185, that's an increase of 85%. That's what they mean. Keeping other variables at constant. But do you know that I can also interpret it in another way to say for every 1 unit decrease, you know, there can be an increase in the GPA, there can be a decrease, right? Now, for every 1 unit decrease in student GPA, the odds of being less likely to apply is also going to be that. You know, when the GPA is increasing, that you may want to be very, that will increase you trying to consider graduate school more likely, and that is by 1.85. But if the GPA is also going down, what happens? You are less likely to consider graduate school. Okay. Oh my God. I really appreciate this. I finished. Sorry that I used additional 1 minute, despite the fact that we know we didn't start on time. This is going to be the end of anything that has to do with relationship. And what we are starting tomorrow is, let me give you the idea of what we're starting tomorrow. We've been looking at the relationship between variables, but you know what we want to do tomorrow? We want to look at the relationship between variable and time. Time. We want to talk about trend, time series. That's how we're going to start tomorrow. Make sure you all stay safe. Is there any question for me? Now you know regression type to use when you have a given research question. And when you come across articles, oh my God, there's a lot of abuse of statistics by researchers from other field. They just use anything. And when they see significant result, oh, they're going to be celebrating. That doesn't make sense, because they're using wrong technique. And that is why at times, whatever recommendation they make will not see the light of the day. And it's going to look as if our models are failing us. When you use a wrong model could work for some time, but it's never going to stand the test of time because it's a wrong model. Just like what I used to say, take a look at this guy. Oh, for those who are online, if I want to do this mathematics, take a look at this. 64 divided by 16. The answer is 4, right? If I do this, I see a 4, but that's by accident. Using this approach will never work all the time. But by accident, it gives me results. This kind of result can never stand the test of time. It is, we normally call it an accidental discharge of nature. It can never stand the test of time. And that's why we got to make use of appropriate technique. Make sure you all stay safe and have a lovely day. Bye for now, everyone.
Thank you.
Yep. You're welcome. Stay safe.
Thank you.